In this video, we present a novel method for agile landing of an unmanned aerial vehicle, UAV, on a moving unmanned surface vehicle, USV. UAVs find applications above water surfaces in various fields, such as area monitoring and search and rescue missions. However, achieving greater autonomy in these operations often requires a carrier ship for takeoff and landing nearby. Since the touchdown maneuver is challenging and should be fast and precise even in rough sea conditions and wave disturbances, we propose a method that employs Model Predictive Control for generating trajectories not only for UAV's landing maneuver but for various phases of its operation. Our method divides the operation of the UAV into three distinct phases: approach, follow, and landing, each of which allows for the generation of relevant trajectories. Compared to existing approaches, our method dynamically modifies the penalization matrices and utilizes multiple sensors for USV state prediction to precisely follow the corresponding states according to the flight phase. Especially during the landing maneuver, the UAV synchronizes not only position and velocities but also attitude with the USV, enabling fast landing on a tilted deck. In the ongoing video, you can observe one of the simulation experiments conducted in conditions simulating a moderate sea environment. At the beginning of the experiment, the USV was located approximately 40 meters from the UAV. Thanks to mutual communication, the UAV knows where the USV is located, and therefore, after gaining altitude and adjusting the heading, performs an approach above the USV's deck. Then the UAV performs a landing maneuver with its heading properly aligned with the USV's. The touchdown is completed as smoothly as possible by taking into account all linear motions and attitude angles of the USV. The system was subjected to rigorous testing through over 1,000 simulated experiments to affirm its reliability and validate its precision. We also compared our method against the most related state-of-the-art method. In comparison to this method, our approach significantly improves both the reliability and precision of the landing process, while also reducing the average landing maneuver time by a factor of 2 on average. We transitioned our work to a real-world environment and validated the system's performance above the dry land using a wooden board to imitate the USV's movement on the water surface. Then we moved our experiments to the water surface, where we tested the landing procedure on a stationary boat, as well as scenarios involving tracking a moving boat and a boat with rocking motions. Through these experiments, we validated that the proposed trajectory planner yields results consistent with those observed in simulations, whereas all computations are performed in real time on board the UAV. The final experiment involved all phases of flight, beginning after takeoff. The individual states of flight and the comparison of the trajectories between the USV and UAV can be observed in the graph provided in the right corner. The UAV has entered the following phase, during which it observes the USV's deck using April tag and USV detection to enhance the accuracy of estimating and predicting the USV's states before executing the landing maneuver.